Hello, welcome again to the basics of electronics. There was a little more confusion from the comments about ones that I made yesterday in the video. Let's start from the beginning. This is your car battery that we all are familiar with. This is a load. This could be a headlight. This could be a fuel pump. This could be a starter motor. This could be anything. We all know we need 12 volts to make the load active, to start the load. Whether it's a fuel pump, like we said, or a motor or anything, a wiper motor, anything. Plus a connection from here to here through a wire, through one side, and then the other side back to the negative. This is our ground return line. Now, from that, we know we have 12 volts over here because we do not lose any voltage through this wire. The other side of it is connected to ground, which means it's 0 volts over here. How much is the total across here? If there's 0 here, there's 12 here, we lose the whole 12 volts from the battery across this lamp or fuel pump or anything for that reason. I highlighted this because this is a wire back to the battery. Next example, you'll see it goes through the engine block. Electrons don't care. Electrons flowing say, as long as I have a return path, a complete path, whether it be through a wire, whether through a middle ground, whether the engine block, a chassis ground, I don't care. As long as I have a complete path back to the battery. Whatever leaves the battery comes back to the battery. Now, let's take an example with this corrosion here. On the positive terminal, there is corrosion. Corrosion is an unwanted substance as far as electricity is concerned. Corrosion introduces resistance. Where if you have resistance and you have current, you have a voltage drop across that substance, so to say. So if we need 12 volts over here and we just got corrosion over here, that corrosion is, let's say, 3 volts. Now, instead of 12 volts, guess how much he'll get? He'll get only 9 volts. Why? Because we lost. That's why we cannot afford to have any corrosion at the terminals. If you ever look, you see that plastic cover to protect the positive on your battery, because that's where the corrosion builds up. So instead of 12 volts here, this has 3 volts across it because it's high resistance. Guess what? Now it's only 9 volts available for him. He says, that's not good. I'm not going to light. I'm not going to be illuminated. We have to clean the corrosion to positive. How about if you have corrosion on the negative? And that's exactly the same thing, high resistance. High resistance now will give you a voltage drop, an unwanted voltage drop or a voltage loss. Remember, voltage drop means this is a voltage drop. I drop voltage across the load because I want to. That's what I need. Voltage loss means I'm losing voltage across something that I don't want to lose voltage. There's a difference. We have a voltage loss, let's say, of 3 volts, just like we had over here. How much will be over here? How much will be over here then? If you look at this now, 3 volts over here will give you 3, instead of 0 volts back to the battery, now we have 3 volts over here. Okay? Now, you have 3 volts because of this high resistance path that was just introduced by all this white substance that corrodes. It looks like you've seen it, probably looks like cocaine and all that, right? You take hot water and then you clean it off, the post and the battery post and all that. So now, this total circuit, this is 3 volts. 3 volts loss, you're going to have a total of 9 volts across this again. You're not going to have 12 volts. You just lost 3 volts through a return wire. So 12 volts minus the 3 volts again will give you 9 volts across this. What does he say? I'm sorry, that's not enough for me to light. That's why it's important. If you have it at the positive, you're going to lose 3 volts. Or whatever. Maybe 1 volt. Maybe half a volt. Whatever. You're going to lose voltage through it. If you have it at the negative, you're going to lose voltage because it's a resistance. You're going to lose at the ground. Same thing. He can't afford to lose more voltage at the ground path or at the positive path. Let's take this return and let's change it. Let's look at the next one. Now, as you've seen before, body sheet metal. We took this and we changed it with the engine block. Does it make a difference? No. Electrons still say we have a path to ground, so they don't care. Same idea, same concept. Can't afford to have corrosion here, cannot afford to have corrosion here. Let's take a step further. This is one brake light. Let's put another one in parallel with it, like we did yesterday. This represents the same thing almost, except we threw in another bulb. This is left brake lamp, this is right brake lamp. And we threw in a fuse. Sometimes I refer to this as a circuit breaker. It's the same purpose, but in technicality, this is the symbol for a fuse. Now, we go over here. We know current flows through the fuse. One side comes out the other side. The current splits up because there's two paths for it to go, some here and some here, equal. So let's say 4 amps, whatever, 2 amps here, 2 amps here, and back to the battery, the negative. Time for a short. Let's say we have a short across it. That's a problem. Now remember, yesterday we talked about shorts. First of all, if you have a short across this area, you see this little wire represents a short. We shorted out this bulb on the left brake lamp. First thing comes to your mind, a short to ground. Is this a short to ground? 100% it is. This is ground and this is a short. First thing comes to your mind. Second thing comes to your mind, a fuse will blow or a circuit breaker will pop, whatever. And therefore, how much will be over here? Actually, I'm shorting the battery is what I'm doing. It's going across the battery, not good. So, with that in mind, the fuse blows. How much should be the other side if the fuse blew? We know we have 12 volts here. We're connected to the battery. How much do we have at the other side over here? We're going to have 0. Why? Because we have no connection back to the battery. Therefore, it's 0 volts. Now, we have another problem. Therefore, this blue. So, from the short, you got an open. The fuse open. You have a short and an open. That's the result. What's going to happen now? We have to find the short. How do we do that? For 100% of the mechanics will go take the fuse, put another fuse in it, because fuses are so cheap. That's not the proper way to do it. The proper way to do it is to take an ohm meter before you put in another fuse from here to ground, to the return path. If you measure 0 ohms or very low ohms, you have to find the short before you put another fuse. Otherwise, you will pop fuse after fuse after fuse. Even though they're cheap, you're not finding a solution to the problem. All you're doing is putting in another fuse, another fuse, another fuse. The short is not going to go away until you find that short where it is. We have a big problem. We have a short to ground. What do? Ohm meter. Ohms. On the other side of the fuse, like I will show you on a hands-on, the other side, if we want to measure ohms, we don't go over here, we measure over here, because the load is on this side. That's what's blowing the fuse. We go from here to here, put on ohms, like I'll show you hopefully in the video, and we'll measure 0 ohms. We say, we take out the light, we take out this light, and then we see which one it is. That's if the short is here. Let me ask you another question. This is the left brake lamp. How about if there's a wire? This represents a wire like this on the right one. Now what will happen? Now, guess what? Same result. We have a short to ground. He'll pop again until we find the one where the short is. So putting in another fuse, no, it's costly. Maybe it's not that costly because they're so cheap, but it's not troubleshooting. Again, we take the ohm meter before we put a new fuse from here to ground, and we go and measure resistance. And we will measure very low resistance, indicating what? Indicating there's a short across here or across here, of one of the lights are shorted. Let's take one other example. There's a short from here to here. Not across here directly, but from here to here. What would be the result? Same result. Why? Because guess where the current is going to go? The current is going to go wherever the short is. It likes the path of least resistance. Whether it's here, whether it's here, whether it's here. That fuse is going to blow. Are we going to put in another fuse? They're cheap. Nope. What are we going to do? We're going to take an ohm meter across this side of the fuse, and we're going to measure to ground, and we're going to measure 0 ohms. What does that tell us? Same thing as before. That tells us we have a problem. Maybe this is shorted. Maybe this wire is now broken and it's touching chassis, which happens a lot. Maybe this wire is broken now and it's touching chassis. Maybe this wire is broken and it's touching chassis ground or engine block or ground. That's how we have to go about it. Okay? Same idea over here. Now, like we said, same thing over here. Here's a resistor, very low resistance. We put it across. Guess what? Now, instead of 3 ohms over here to 6 ohms over here, now we have 0 ohms. When you have 0 ohms with Ohm's law, guess how much the current is? Yep, 12,000 amps. What battery in the world can deliver 12,000 amps? If you ever see a booster, the peak amps are like 1,000 amps, right? So obviously, a short across here, across the bulb itself, across here, will give us the same result. This will blow the fuse. We have to find first the short before we put in another fuse. An open. Again, we discussed this yesterday, an open. Where's an open? Guess what, where the open is? This is a connector. Let's say this is one wire of the connector. This is the other wire of the connector. Right here. See this? You see this switch over here? It's closed. See this switch over here? It's closed. We're going to open this one. How much are we going to measure over here with this open? If you said 12 volts with this open, you're wrong. We measure 0 volts. Why? Because we're not connected anymore to battery voltage through the fuse. We lost our connection. That's one. Other reason, 0 current going through here. 0 current, 0 voltage, Ohm's law. Now, so we measure 0 volts over here. Right here, because this is open. How much are we going to measure over here at the fuse? If you said 0 volts over here, you're wrong. 12 volts. Why? Because we're still connected to the battery. Where is the open? Not here, not him. He didn't blow. The open is here. Therefore, after the open, you're going to lose the voltage. You're going to be 0 volts. Before the open, you're going to have 12 volts. Or alternator. If the alternator is running, engine is cranking, you're going to have 14 volts. Remember that. 14 volts. So therefore, the cigarette lighter or the adapter where you put in your phone to charge, and if you go in there and you measure it and you measure 0 volts, what does that mean? That means could be the fuse anywhere along that line. I lost my voltage. How about this one over here? Same thing as here, right? This is open now. This is open. How much should I measure over here? 0 volts. How much over here? 12 volts. Why? Because this is still connected through the fuse, through the battery. 0 volts over here. How about over here? This is broken. This wire, let's say this is a blue wire. This blue wire, before it got to the splice, it goes to splice, it just broke off. How much am I going to measure here? How much am I going to measure here? Since we have no connection going back to the battery, guess what? 0 volts here and 0 volts across each. Both will be extinguished or not illuminated, not lit. When we see that, we know there's a common one causing both. If I see this one over here, if I see the left brake lamp, first thing comes out to my mind, obviously it's the bulb, right? Let's say I change the bulb. Then I have to look for where? An open. Where? Here? Nope. You're not going to find an open over there. Why? Because if there's an open over here, it'll knock out both lights. You only have the problem with this light out. What will cause that? This wire over here. Let's say this is lit and this is extinguished. You change the bulb. You said, oh, that's easy. Easy fix. That's the bulb, right? You change the bulb, same thing. Where's the open? Is it over here again? Nope. Why not? Because both will be off. This is a common to both, see? Where would be the open? Anywhere from here to here. In this case, maybe the switch. Maybe this wire broke off. Maybe this wire after the switch. Maybe the wire before the switch. Maybe the ground. Maybe this one goes to ground. Maybe this broke. I come over there, and guess what? I see both lit lights, not lit. Both of them. What could be the problem? Okay. Can the problem be that the fuse blew? 100%, of course. Can the problem be that this wire is broken? Yes, and that will knock out both. Can the problem be a ground? Yes, 100%. Why? Because notice at this splice, current goes here, current goes here. They both come back to a common point to get back to the negative. If you have a broken from here to here, you'll knock out both. If I have again open from here to here, it'll knock out both. If I have a blown fuse, it'll knock out both. If I get a wire over here that's broken from positive to here, it'll knock out both. It depends what you're looking for. So if you have a problem with your bulbs, always notice the other one. Is the other one lit? That just cut off your troubleshooting time to fit by 50% or more. Okay? Again, the headlamps. Left is good, right is not good. Okay, I know I'm dealing with, obviously with something with this one. Has nothing to do with a fuse because the fuse will blow both. Right? Has nothing to do with a bad ground because if it was a bad ground, both of them would be out. It's a common point right here. So please go to my channel, Joe, Electronic Schematics for Auto. My other one, Automotive, Electronic Schematics for Joseph. I hope this cleared things a bit up because I got quite a few comments about how confusing it is. And it is confusing. There's no doubt about it. There is nothing more confusing than not just to analyze how it works, but to analyze why it doesn't work. That's the true skill of a technician. Okay, I hope you understood this. Like I said, please go to my channel. Now, I want to thank the support of all the viewers for letting me become monetized. It was a quite accomplishment. So, again, Joe, Electronic Schematics for Auto. Please give me a like if you like it. And if you disagree or you don't, also, dislikes are welcome also. The purpose of now, since I got monetized, is to increase and improve the quality of every single video, of every single lecture, of every single tutorial, to come across in a simplified manner to whatever background you have. Make sure you understand what we just said in the last 18 minutes. I don't want you to understand 2 minutes. I want you to understand 18 minutes of this video. All right? That's the purpose. There's much room to be improved in these videos. Believe me, a lot of improvement to be done. Like I said, Automotive, Electronic Schematics for Joseph is the other channel that I'm going to be working on now since I got the other one monetized. Thank you so much. Oops.